In this video, we are going to be looking at ratios. So ratios are a comparison of one quantity to another, and typically we write them as fractions, although we can also write them using a colon, which we will see later. Okay, so we are going to start on page 267. Just like we did in the previous video with our percentages, we want to try and do some ratio problems just mentally. So on page 267, the first question says, if 15 cupcakes cost $3.36, how much would the cost, or what would the cost of 38 cupcakes be? So it says, we can certainly solve this problem through a proportion. However, the challenge today is to solve this using only a ratio table. So like I said, just like we did with our percentages, let's try and do this mentally. So we want to build our way up to 38. So how are we going to do that? So maybe we could start with 30. So how would we go from 15 to 30? That would be doubling. So if we double 15, so 336 doubled would be what, 672, I believe. Yeah, 672. All right, and remember our goal is to get to 38. So again, just like before, there are lots of possibilities for ways that you can do this. So if you want to go ahead and try this on your own, it may not be exactly what I do, but if we were in class, I would be asking you, like, tell me what to do next. But we don't have that ability in this online class. So let's see. So maybe next I would do, let's say 5. So I could go from 15 to 5 by dividing by 3. So 15 divided by 3 is 5. So 336 divided by 3. So 5 cupcakes should be $1.12 if we're dividing by 3. All right, and then let's see, this would be 35, so we would need 3 more. So 3, if we go from 30 to 3, we could divide 30 by 10. It's a little redundant. Divide 30 divided by 10 to get to 3. So that's just going to move the decimal point. So it's going to be like 0.672. So let's just say this is 67. All right, so then 38 of them. If we add 30 plus 3 plus 5, that should be 38. So 672 plus 112 plus 67 cents should be about $8.51. So 38 cupcakes should cost $8.51. All right, and then the second one, it says if a box of 36 picture frames cost $86.40, then how much would 5 picture frames cost? Okay, well, how are we going to get to 5? Let's see. Let's just maybe take the long way to do this. How about 18 first of all? So we're just dividing in half. So again, you can do whatever you want. So half would be, what is that? 4220? 4220? All right. Let's see. Can I do, what would I want to do next? How about 6? Would 6 be easy to do in our head? Divide 18 by 3. So dividing by 3. So that would be 1, 4. What is that going to be? 1407 if we round. It's like 14.066666666. So if this was 21 cents, that would round up to be 7. All right, now what? How about, oh, what can we do? Let's see. How about half of that? I don't know. Divide. Maybe you found a more efficient way to do this than I have. Let's do 3. So let's see, that would be 7. And then this would be 3.5 cents. So let's call that 7.04. So now what? We're trying to get to 5. So, oh, what if we did, so this is like a roundabout way. We probably didn't need these other facts now, but what if we did 30 and did 36 minus 6? So 8640 minus 1407, that's about 7233. And let's see, if we divide by 6, we could get to 5. So 30 divided by 6. So we should be able to do this in our heads. So 6 goes into 7 one time. That would leave us with 12, which is 2. And then 6 would be, let's see, 5 cents would be 30. So it's like 5.5. So that would probably round up to be about 6 cents. So 12.06. So again, you probably found a more efficient way maybe than what I just did, but just winging it to see. Okay. So again, keep in mind that we rounded along the way, so this may not be exactly the answer that you're getting. I think the true answer is probably 12 if we did it another way, but I am looking for you being able to do some mental math and justify your reasoning. So if you round along the way, then that is totally fine. All right, so let's look at some other questions involving ratios. So now I'm jumping, this is going to be, we're jumping around a lot. So looking at page 273 next. So in 273, it says, what ratio represents green to red dots? And it says find 3 different relationships. So here, these don't quite look like dots, but they're little squares, and no on the calculator. So what are some ratios that you could make? So you could count individually. There are 6 red for every 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 green. That would reduce down to be, if you look at, let's say, just one row, there's 2 red for every 6 green. So if I divide by 3 and divide by 3, so the idea is that these should be proportional, so they are changing in size at the same rate. What else? 2 to 3 could be broken down as there's 1 red for every 3 green. We could go up and say there are 4 red if we double, 4 red for every 12. If we do 3, 1 and 2 make 3, so 6 and 3, that would be 9. So there always should be 3 times the amount of green compared to red. Okay. And then same thing down here at the bottom. It says use a table to solve the following and write the action that was done. So just like we did before on that previous page, how would you go from 12 and 18 to this would be 6 and this would be 9. So this one is the given. So we are taking half of row 1. So 12 divided by 2 makes 6. 18 divided by 2 makes 9. How would you go from 9 to 54? 9 times 6 makes 54. So 6 times 6, this should be 36. So we can take see, what did I just do? 6 times row 2 to get row 3. Let's see, to get row 4, how about, instead of using 36, what about 6? 6 divided by 3 makes 2, so 9 divided by 3 would make 3. So you could take row 2 divided by 3 for that one. To make 30, what if we take 36 minus 6? So row 3 minus row 2. Again, you can do these in lots of different ways to get your answers. So 36 minus 6 makes 30. So 54 minus 9 would be 45. All right, and then how would we get to 8? Let's say we have 6 and 2, so how about row 2 plus row 4? All right, so row 2 plus row 4. So 6 plus 2 is 8, so 9 plus 3 would be 12. Now, how could we get to 42? Let's see here. 36 plus 6, I believe, is 42. So how about row 3 plus row 2? So 36 plus 6 is 42, so 54 plus 9 would be 63. And then 27 over here on the right. So what's jumping out to me is 18 plus 9 would be 27. So 12 plus 6 would be 18. So this would be row 1 plus row 2. All right, so notice that we did all of the operations. So we did some addition, we did a subtraction, we did some division, we did some multiplication. So whatever operation you want to use in order to fill in this table, again, I just want to see what you're thinking about as you're doing this. And they, again, should be proportional, changing at the same rate. Okay, and then on the back, let's see. 274, it says build a ratio table to solve this problem. So a person who weighs 160 pounds on Earth weighs 416 pounds on Jupiter. So if a person weighs 120 pounds on Earth, how much will the person weigh on Jupiter? So we got to get to 120. So this is the given. So let's try and figure out how we can get to 120. So how about we start by doing like half? So row 1 divided by 2. Hopefully I don't run out of space. All right, so if 160 is 416, then 80 would be half of that, so 208. And we're trying to get to 120. So, okay, so let's do like half again. So let's do 40. So row 2 divided by 2. So half of 80, or yes, half of 80 is 40. So half of 208, 40 would be 104. And then now we have 160 and 140. So that should be able to get us to 120 if we take row 1 minus row 3. So 160 minus 40 is 120, so 416 minus 104 would be 312. So on Jupiter, you would weigh 312 pounds if you weighed 120 pounds on Earth. Okay. Okay, so let's see. It says build ratio tables like the one above to solve these 3 problems. Okay, so the first one, there are 12 boys for 16 girls. So down here. At this rate, how many boys are there if there are 28 girls? So we have 12 boys to 16 girls. And we're trying to get to 28 girls. So what can we do to get to 28 girls? So let's see. How about, I don't know, let's just start trying some stuff. So let's do like half. So how about half would be 6 and 8. Half of this again would be 4 and 3. So then 16 plus 4 would be 20, plus 8 would be 28. So you could add all of these together. So 16, 17, 18, 19, 20, 21. So there would be 21 boys. This is A. So again, whatever you want to do to show your ratio table. For B, 3 cups of water weigh 12 ounces. So how much will 10 cups weigh? So cups and weight. So 3 cups weigh 12 ounces. So how much will 10 cups weigh? So let's try doubling this. So 6, 24. Oh, what else could we do? How about, I mean, we could double again. Is that going to help us? Maybe not. 12 and 48. And let's see. We could actually go back and do 3 cups for 12. So if I divide by 3, I can figure out what 1 is supposed to be. 1 would be with 4. So then 3 and 6 and 1 make 10. So 3 and 6 and 1. So that would be 36, so 40. So 10 cups would make 40. And then C, the 15 cupcakes that cost $3.36 was already on this page. The 15 cupcakes for $3.36, find 38 of them. So we actually already did C, so I'm not going to do it again. Okay, now let's try some more word problems. So now again, I am jumping to page 277. We're going to skip the top because I don't have any Smarties, or at least I don't think so. Let me check. You're in luck. I do have some Smarties left over from Halloween. So here's a package of Smarties. I don't know how well you'll be able to see the colors, but we can make some ratios with these. Let's see. So orange, there are 1, 2, 3, 4, 5 orange ones. For yellow, I have 3 yellows. I have 3 pink ones. Oh, I might have messed this up. Let's see. I have no green. There are 2 purple. Oh, I messed this up. I read white as orange. So, sorry. Orange is orange, which is down here. That's the actual 5. Let me fix this. So, white, I have 2 white ones. I misread my packaging. Okay. So sorry. So what's the total? So I should have, what, 15 of these? Okay, so let me move these out of the way. All right, so if I wanted to make ratios of these, so ratio of yellow to pink, there are 3 yellow for every 3 pink. So here's where I was talking about you can write ratios with a colon. And then if you want, you could reduce this down to be 1 to 1. Green to orange, that's 0 to 5. My purple to total is 2 to 15. And then my total compared to white would be 15 to 2. Okay, so that is a look at some ratios. Okay, so then what about some problems? So it says, suppose several packages of Smarties have been opened and placed into various boxes, so solve the following problems. So if the ratio of white to green is 5 to 8, so white to green is 5 to 8. If there are 80 whites in box A, then how many green would there be? Okay. So again, we can do this in lots of different ways. Maybe you want to set up a proportion. Maybe you want to just think about multiplying. So like, how would you go from 5 to 80? So you would multiply by, oh, what would that be? 1, so 18. So 8 times 18. So maybe you want to set up a proportion. So 5 to 80 is 8 to something. I don't know what, let's see, 8 times 80 would be 640. So that would be, dividing by 5 would be 1. Let's see here, 128. So as I said, what, this was 5 times 13, so 8 times 13. No, let's see, 16. 5 times 16 makes 80, so 8 times 16, yes, is 128. Okay. What about the next one? In box B, the ratio of orange to purple to yellow. Orange to purple to yellow is 5 to 3 to 2. So if there are 48 purple, how many orange and yellow would there be? Okay, so again, you could set up proportions if you want, or how do you go from 3 to 48? That would be multiplying by what number? That again should be multiplying by 16. So 5 times 16 would be 80. And then 2 times 16 should be 32. So you should have 80 and 32. Okay. How about you take a second and try the other two down here at the bottom, 5 and 6. So pause the video, and when you're done, unpause it, and you can check your answers. Okay, so for 5, the ratio of green to pink is 4 to 5. So if there are a total of 180 green and pink in the box, how many green and how many are pink? Okay, so this one, right now we currently have a total of 9, and we want a total of 180. So how would we scale up from 9 to 180? We would multiply by 20. So that means each one also scales up by 20. So 4 times 20 should be 80. 5 times 20 should be 100. So there would be 100 green, or sorry, there would be 80 green and 100 pink. All right, and then in number 6, the ratio of green to white to orange is 3 to 4 to 5. So if there are a total of 600 Smarties, how many are white, how many are orange, and how many are green? All right, so our current total is, what, 12? All right, so we want to scale up to having 600. So 12 times what is going to give you 600? That's actually 50. So if we scale up all of the other colors appropriately, so 3 times 50 would be 150. 4 times 50 would be 200, and 5 times 50 would be 250. So there's 150 green, 200 white, and 250 orange for a total of 600. Okay. All right. Next, 2 problems on the back on page 278. So again, why don't you go ahead and try these on your own and then unpause when you think that you have the answers. Okay, so for problem number 1, we have different colored sprinkles. So we have pink, blue, and green. So let me write that first. Pink, blue, and green. So what are things that we know? There are 3/5 as many pink sprinkles as blue sprinkles. So that means right now for every, if it's 3/5 as much, that means for every 3 pink, there are 5 blue. The ratio of green sprinkles to pink sprinkles is 2 to 1, and there are a total of 18 pink and green sprinkles. So let's wait on this little fact for the time being. If green and pink is 2 to 1, that means for every 2 green, there's 1 pink. And we want a total of 18. And right now, what is the total? The total is 3. So we want pink and green to get up to a total of 18. So how would you scale up from 3 to 18? Well, that would be, what, times 6? So 1 times 6 would be 6, and 2 times 6 would be 12. That would make a total of 18. So we know there are 6 pink, and we know there are 12 green. So then going back to the fact about blue, there are 3/5 as many pink as blue. So we know it's 3 to 5. So if we double that to get to 6, we can double the blue. So there should be 10 blue. So 6 and 10 and 12. So I hope you got that correct. All right, and then problem number 2. Let's see, the ratio of purple to orange. So let me write out purple. So we have purple and orange and yellow in this problem. Okay, so let's see what we know. Purple eggs to orange eggs is 5 to 2. Okay, so for every 5, we have 2 orange. There are half as many orange as yellow. And the difference between purple and orange is 36. So let's hold off on this middle clue about yellow, since the first one is about purple and orange and the last one is about purple and orange. The difference between them has to be 36. So what is the difference right now? The difference right now is just 3. So we want the difference to be up to 36. So how would you scale up from 3 to 36? You could multiply by 12. So if we take 5 times 12, that would be 60. And then 2 times 12 would be 24. So we know there are 60 purple and 24 orange. Okay. And then there are half as many orange as yellow. So orange is half the size of the yellow. So if we double the yellow, there should be 48 yellow. All right, so that is some problem solving involving some ratios. All right, and then again, we're going to go back a little bit. There are like 2 more activities that I want to go ahead and show you. So now jump back to page 271. Get my Smarties out of the way here. Move my computer a little bit. Okay, so in 271, this is just kind of like a table that sums up everything that we have already talked about related to ratios. So with question number 1, it says the number of reds you have is 2 compared to the number of blue, which is 1. So sorry, this is a little blurry because of my camera, but if I scoot it down, maybe you can see it better. All right, so if you have 2 red things for every 1 blue thing, the ratio of red to blue would be 2 to 1. So then if I ask you for the ratio of blue to red, you would just flip it around. There would be 1 blue for every 2 red. Okay. So then the number of red is how many times the number of blue. So you have 2 times the number of blue. So red is double the number of blue, which means if you compare blue to red, blue is how many times the number of red? Well, there's 1 for every 2, so it's half the size. So this is 1/2. And then it says red makes up what fraction of the total? Oh, these are tiles. Okay, so red makes up the total how many tiles? Red, there are 2 tiles out of how many total? So 2 and 1 make 3. So red would be 2/3 of the total. And then blue makes up 1 fraction. Well, if red is 2/3 of the total, Blue is going to be 1/3 of the total. All right, so again, why don't you take a couple of minutes and try and fill out this table. There is always one square where you know information, and based off of that, you should find everything else. So take a minute and see if you notice some patterns and fill in this table, and then unpause the video to check your answers. Okay. So for question 2, if the ratio of red to blue is 3:1, we know that means there are 3 red for every 1 blue. This would also mean, I'm going to be jumping around a little, that red is 3 times the amount of blue. So then what does that mean in terms of blue? If the ratio of red to blue is 3:1, we flip it around for blue to red. So that would be 1:3. And blue would be how much the size of the red? It would be 1/3 the size of the red. There's 1 for every 3. So you should notice the pattern of the ratios are matching up with the number of times. And then the ratios are also matching up. Okay, and then the fractional total. So red is 3 out of 4 tiles, which means blue is 1 out of 4. Okay. All right, so the next one, question 3. If blue to red is 3:4, red to blue would be, flip it around, 4:3. So there are 4 red for every 3 blue. So the number of times red is compared to blue, there are 4 red for every blue, so it's 4/3 as many, so 1 1/3 times. And for blue to red, we'd flip it around, it's 3/4 of the size. And what fraction? Red is 4 of 7 total tiles, and blue is 3 of 7 total tiles. Okay, for question 4, red is 2/3 the size of blue. So that means for every 2 red, we have 3 blue. So 2 red for 3 blue. Blue to red, flip it around, 3 blues for every 2 red, which means blue is 3/2 the size of the red. And our fractions, red is 2 of 5 tiles, and blue is 3 of 5 tiles. So 2/5 and 3/5. All right, question 5. Over here, the number of blue. Blue is 5/6 the size of red. So that means there are 5 blue for every 6 red. So therefore, red to blue, flip it around, 6:5. So 6 red for every 5 blue. So the number of red is 6/5 times the number of blue. Red is what fraction of the total? 6 out of 11 tiles. And blue would be 5 out of 11 tiles. And then finally, question number 6, red would be 3/10. So that means blue has to be the rest. They would be 7/10. So that means we have 3 red for every 7 blue. So 3 red for every 7 blue, which means we have 7 blue for every 3 red. The ratio, red is 3/7 the size of the blue, and blue is 7/3 times bigger than red. Okay, so just a little comparison activity, noticing some patterns. All right, and then the very last thing, this is our last activity in Math 201, aside from you doing some homework and a quiz and a final. Page 272, looking at some candy bars. So these are kind of tied to the table that we just made. So question number 1, here's the idea. This is a candy bar, and we want to cut the bar into 2 pieces, an A piece and a B piece, so that it represents the given description. So for number 1, this should say 1/2. Part A is half as large as part B. So how would we figure that out? So off to the side, if you want to draw a picture. So for example, if this is the B candy bar, A has to be half the size of B. So what would A look like? So you would want to chop that into 2 parts, and then A would be half the size. So when we go to make this candy bar, to show the cuts, how many pieces am I going to need? I'm going to need 3 pieces, right? So this part is the A part, and here is the B part. So A is this 1 piece compared to B is 2 pieces. It's half the size. So then B is how many times as large as A? So it is 2 pieces for every 1 piece. So it would be twice as large. A is how much of the full candy bar. So it would be 1 of 3 pieces. So this is like, again, in that table we just did, where it asked for the fraction instead of the ratios. And then what would the ratio of A to B be? There is 1 piece for A for every 2 pieces to B. Okay. All right, how about number 2? This time it says A is 1/4 the size of B. So that means for every 1 piece of A, there should be 4 pieces for B. So it's 1/4 the size. So that means we need a total of 5 pieces. So if B is this big, A has to be 1/4, so 1 of those 4. So B is how many times as big as A? It's 4 pieces for every 1 piece, so it's 4 times larger. A is how much of the candy bar? A is 1 out of 5 pieces, so it's 1/5. And then what is the ratio of B to A? There are 4 pieces for every 1 piece, so 4 to 1. All right, so we did 2 together, so do you want to try 3, 4, 5, and 6 on your own? I know these are hard to read, so in number 3, this should say 2/3, and number 4 should say 4/5. So 2/3 and 4/5, and then try 5 and 6. So pause the video, and then we will check answers. All right, number 3. So A is 2/3 the size of B. So for every 2 A pieces, there would be 3 B pieces. So that means there are a total, again, of 5 pieces. So 2A and 3B. So B is how many times as large as A? There's 3 pieces for every 2 pieces, so it's 3 halves. A is how much of the full candy bar? It is 2 of 5 pieces. And the ratio of A to B, there are 2 pieces for every 3 pieces. So 2 to 3. Okay, number 4. A is 4/5 the size of B. So for every 4 pieces of A, there are 5 pieces to B. So we need a total of 9 pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so B is how many times as large? B is 5 pieces for every 4A, so 5/4 the size. A is how much of the whole candy bar? It's 4 pieces out of 9 total pieces, so 4/9. And the ratio of B to A, 5 pieces for every 4A pieces, so 5 to 4. Number 5, now it's giving you a ratio. The ratio of A to B is 3 to 2. So for every 3 A pieces, there's 2 B pieces. So we would need 5 pieces total. So 3 to 2. A then would be 3 halves. That's times as large as B. B is what fraction of the whole candy bar? 2 out of 5 pieces. And B is how many times as large? So B is 2 for every 3 pieces, so it's 2/3 the size of A. So if A is 3 pieces, B is only 2 of those 3 pieces. And finally, number 6, ratio of A to B is 3 to 4. So for every 3 A pieces, there are 4 B pieces. So that means we need 7. 1, 2, 3, 1, 2, 3, 4. B is how many times as large as A? 4/3. So 1 1/3 times bigger than A. A is how much of the whole candy bar? It is 3 pieces out of 7, so 3/7. And then finally, A is how many times as large as B? A is 3 pieces compared to 4 pieces, so it's 3/4 the size of B. All right, so we are finished learning brand new content in Math 201. So next week you will be having a quiz over these percents and ratios, the 2 videos from this week. So that quiz will be next week, so be studying up on that. And you can also start preparing for your final. If you have any questions, let me know.